If you need to find the domain of a function, sometimes the easiest thing to do is to figure out what the domain can't be. Keep watching and I'll explain. Welcome to Math Bytes, I'm Allison, and today we're talking about finding the domain of a function. Sometimes the domain of a function is stated outright, but if it isn't, the domain of a function is all values of the variable for which the function is defined. To put that another way, if you pick a value for the variable that makes the function undefined, then that value will not be part of the domain. Where are functions undefined? Well, when we're working in the set of real numbers, a denominator equal to 0 is undefined. Taking the square root of a negative number is undefined. These are the types of situations that make a function undefined and put restrictions on domains. Let's take a look at a couple of examples. Sometimes the easiest way to find the domain of a function is to figure out what values can't be in the domain. Let's look at an example. Okay, here we have f of x equals 7 over x plus 2. All right, where would this function be undefined? It would be undefined when our denominator equals 0. So our denominator, x plus 2, equals 0 when x is equal to negative 2. Is there anywhere else? No, that's the only place where the denominator is going to be 0, and there isn't anything else that'll make this function undefined. So the domain for this function is all real numbers except negative 2. Let's write it in set notation. That looks like this. And how you read that is all x for x not equal to negative 2. Let's look at another example. We have g of x is equal to 2x minus 7. Is there any value for x which will make this function undefined? Are we in any danger of dividing by 0? No, we don't have a variable in the denominator. Are we taking square roots that might be negative? No, we're not. This is just the equation of a line. There isn't any value I could put in for x that would make my function undefined. In other words, there isn't any value I can put in for x that won't give me a real number back out again. So in this case, the domain is all real numbers. There are no restrictions on this domain at all. Okay, let's look at a couple more examples. Here we have h of x is equal to the positive square root of 9 minus x. All right, so what are the restrictions here that we might have? We can't take the square root of a negative number when we're working in the set of real numbers, which we are, so that's a restriction here. What about 0? Can we take the square root of 0? Sure, that's fine. So it would be okay for what's under the square root symbol to be 0, but we can't let it be negative. So first of all, let's figure out where it's 0. 9 minus x is equal to 0 when x equals 9. Okay? Now, we need what's under that square root symbol to be greater than 0 for this function to be defined. So we need 9 minus x to be greater than 0, or x to be less than 9. So our domain will be all real numbers for x less than or equal to 9. And that will be the domain of this function. Let's look at another example. We have r of x is equal to 1 over the square root of 9 minus x. Okay, now we just saw in our previous example that in order for that what's under that square root symbol to be positive, we need x to be less than 9. So we know that. The question here is, can x also be equal to 9 as it was before in the previous example? No, because if x were equal to 9, we would now have a 0 in the denominator. So the domain of this function will be all x for x less than 9, not less than or equal to 9 as it was in the previous example. So you have to really watch those subtleties and make sure that you're covering all your bases where your function could be undefined. Finding the domain of a function is often just the process of elimination. Figure out what can't be in the domain and exclude it, and all other real numbers can be there. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if you have something you'd like to ask us or a topic you'd like us to discuss, just send us an email. We're at contactmathbytes@gmail.com, and we will see you next time.